Okay, so hi guys, it's me again, and in this new video, I'll be teaching you guys how to set up your RobotC so that you can start commanding motors to move. Now, this is accomplished via something called the Pragma, and the Pragma config is basically something that tells RobotC where you've put what. So, RobotC, like any other language, cannot magically know in where you've connected this motor or this sensor or this servo. So, you're gonna have to tell it in your program so that you can command those motors that you've connected. So, let's get right to it. So, now, I'm assuming that you would have connected your electricals by this point in time, and you will be taught to do that in future videos in the mechanical side. But anyway, so as you know, for just a basic overview, there are 4 sensor ports on the NXT brick, and well, to plug in Tetrix motors, you need something called a high-technic Tetrix motor controller. And those motor controllers have NXT data cable ports. They have 2. So, first one of them you can plug into the sensor port. So, say sensor port 1 on the NXT brick. And from there, you take the second one out and daisy chain it. And we'll be teaching you how to daisy chain once again, so don't be scared if you don't understand. So, okay, so to open our Pragma config, we have to go to Robot, and under Robot, to Motors and Sensor Setup. So as you can see here, we have our motors and sensors. And you can see that there are only 3 motors right now. These are the standard NXT Lego servo motors that come with any NXT kit. And since you haven't told RobotC that you are going to be using some Tetrix motors with some high-technique motor controllers, it assumes that you're only using the 3 motor ports provided on the NXT. Now, so to add Tetrix motors and stuff, what you want to do is go to external controllers right here, this tab. So once you go here, you see that there's a bunch of options, and you might not know what this means. So the first one says standard Tetrix configuration. 1 Tetrix motor controller and servo controller on sensor port 1. What this will do will make your first device a motor controller and your second device a servo controller. And then the standard matrix controller, which most of us won't really care about because we're not using matrix. Now, I want you to go ahead and select custom because rarely will your electricals align with this model. So just go ahead and select custom, and this will become open to you. So as you can see, you have the freedom to connect any 4 devices into 1 motor port. Now, let's say into 1 sensor port, sorry. So let's say you're using your standard 8 allowed motors for FDC. You're using 8 DC motors, which are allowed. So in that case, you're gonna want to say Tetrix motor controller, daisy chain to another Tetrix motor controller, daisy chain to another Tetrix motor controller, daisy chain to a final 4th Tetrix motor controller. So now, as you can see, you have 4 motor controllers with 4 different with 2 DC motors in them each, which gives you 8 motors in total. Now let's say you want to add a few servos. So okay, let's put a servo controller here and a servo controller here. And you can change this around according to your needs. But remember, once you connect a motor controller or servo controller into a port, that port is gone, so you cannot use it for sensors. So be judicious, I guess, when you're doing this, and we'll teach you how to do that later. So don't just be hasty to click OK yet. So you've set all this up, so go ahead and go to motors. Now as you can see, they have MTR S1C11, right? And you now have 1, 2, 3, 4, 5, 6, 7, 8 new motors, named motor D, E, F, G, H, I, J, K. So, now, some of you might be wondering, what does this mean? Well, it's pretty simple. MTR stands for motor, which is pretty obvious, I guess. S1 stands for which sensor port you've connected it into. So, take this one. So, sensor port 1, all of these are connected and daisy chained into sensor port 1. Now, C1 stands for controller 1. Now, per controller, you have 2 motors. So, this is the first motor of controller 1, and this is the second motor of controller 1. So, it's pretty simple to understand. So, now, another cool thing you can do is you can go ahead and name this motor whatever you want it to be. So let's say I'm using this for my right wheel. I could say right wheel. And in the future, whenever I want to code anything with this program, I just need to type right wheel and then motor right wheel and then assign a power and it will move. And I could call this left wheel. And so on and so forth. You could call it everything. Now, these options are, there's only one option, which is motor equipped Tetrix. They're assuming you're using the standard DC Tetrix motor, which you should be using. Now, coming over here, you have a bunch of options enabled over here. Now, what does reversed mean? So, what happens if you check reversed? So, for example, in your driving base, if you stick one motor on the right side of your robot and a second motor on the left side of your robot, those motors are flipped in relation to each other. They are not facing the same way. Obviously, they shouldn't be, typically. So, if you command both of them to move forward, which you're assuming will make both of them move forward and make the whole robot move forward, it won't happen because they're flipped. So, what will happen is one side would move forward and the other side would move backward. So, this is why you need to take the reversed in scenarios like this. When you take the reversed, what happens is, if you command something to go forward, it'll move backward. And if you command something to move backward, it'll move forward. So that's just what reverse does. Now, an encoder. So an encoder is something special you can add onto your motor. So now what you can do with this encoder is so it is a separate part, a mechanical part that you need to attach physically onto your motor and onto the controller. So an encoder measures the number of rotations, just like how you can measure in a Lego servo. So that might help you guys with a lot of stuff, but let me tell you, encoders aren't particularly reliable. They're good, but they're not very, very dependable. So, if you've attached an encoder, let's say you want to measure the distance the thing has traveled, then you select this option. Now, what is PID control? PID control basically is something that helps us make sure that the robot is going straight. I forgot what PID control is. PID stands for, and I will include a link to another video that'll explain PID in great detail, because I've forgotten exactly what it is But as I remember it, um, I think that PID basically helps both two motors to or a motor to like travel properly at the same speed you command it. It prevents any fluctuations in the speed, and if you, for example, PID control two linked motors, then they will travel at the same speed no matter what, even if one motor gets obstructed for whatever reason. So, yeah. So, I'm sure that's not too clear a thing for you guys, but I will definitely include a link to another helpful video on what exactly PID control is and how you can use it. So whatever, you can check this and then you can change your motors names accordingly and then that'll become done. So next, let's head over to servos. So we have 12 servos and these little things here, they're the same. As with the motors, you can name your servos whatever you want to name them. It'll work. And here you see the type, no servo. Well, as you know, there are two kinds of servo. A standard servo, which would move only 180 degrees, and you can command in RobotC with positions, and a continuous rotation servo, which moves all 360 degrees, and which you can command in RobotC with which is actually pretty much a pain to program in RobotC. It's kind of confusing. So I will show you guys how to do it. So we have two servo controllers, and each servo controller has space for six servos. So that's why when we put in two, we have six, and it says S2, which means we've plugged it into S2. So great. Great. Now we have whatever. You can set it to standard servo and continuous rotation according to your needs. If you set it as no servo, it will think that there's nothing there. So if in fact there's nothing there, set it to no servo. Otherwise, please do set it to whatever servo is there. Finally, in the sensors option, we have put an external controller here, and we have put an external controller here. Now, you can name this sensor port whatever you want. It typically doesn't do much if you've put an external controller there. So I would urge you to leave both S1 and S2 blank in this imaginary scenario where you have both things. Now, let's say for the autonomous, you're going to put your IR sensor, which you're going to probably need if you want to drop in the center structure and other stuff in other years. You're going to want to go to high technique IR Seeker 1200. It sets that as a port, and now you can call the IR Seeker IR. And similarly, if you're using a gyro sensor, which I'd recommend and which I'll teach you how to use properly later, then you're going to want to say high technique gyro, and you're going to want to call this gyro. So, okay, so we've pretty much finished our stuff, right? Over here, yeah, in this sensor management thing, you're going to want to click allow third-party sensors from High Technic or RCX or whatever you're using. And if you're designing some new sensors with your Super Pro Proto board and stuff, then you're going to want to do that as well. And you can just let this go. I mean, yeah, just let this go. This will become important maybe in a later video on Robot Virtual Worlds. But otherwise, this is okay, so go ahead and click OK, and you will see that RobotC will automatically generate our whole Pragma for us. So, I know, this looks pretty complicated to people who have just come here for the first time, but as you can see, it's a pretty simple thing to do. It's not that hard. So, you can easily understand what this thing is saying. So this is saying hash pragma config starts off every line, and this is saying hubs. In sensor port 1, we have a high technique motor, a controller daisy chain to another one, to another one, to another one. In S2, high technique servo daisy chain to another one, and then nothing, nothing. And then S1, S2 has these controllers. IR is in S3, gyro is in S4, and then as I told you, it says the name of the motor as we have assigned it, or servo as we have assigned it. It says a Tetrix motor, which is what the motor is. It says open loop, which is all motors, and reversed and encoder based on whether or not you have told it you have selected reversed or PID control. So yeah. So congratulations. If you followed these steps and stuff, you have gotten one step closer to moving your motors and doing something cool with them. And you can, see that you've generated all this complicated stuff pretty easily. So yeah, and in the subsequent videos, I'll be teaching you guys how to make use of this Pragma and use these names that you've assigned to code stuff. So thanks a lot for watching, and as usual, if you have any questions, please ask in the comment section below.